So what I wanted to do today is I want to show you guys how to do the vector lab. So the first thing I'm going to do is I'm going to show you how to get to it. So I've got my class screen, my home page, to look like a student. So you just go to course materials and you hit content. And then once you get to content, what I usually do is I just hit whatever the first page is. And then obviously you want to read this stuff, but you want to go to this sidebar. And the first page that has this, here's our vector addition lab. So we just head here and we click on this, and then it'll download. And mine shows up here, but it also shows up in my download folder. So I'm gonna pull it up. And okay, so here's what I've got. Here's my lab. And then I'm going to go ahead and minimize the screen because I don't need that part anymore right now. And I'm going to click on this PhET simulation. And it's going to go to this page, and it's going to want me to download the simulation. So that's fine. I'm okay with that. And then when I get to downloads, it's going to tell me it's not going to open because it's from an unidentified developer. So I'm going to go to my security settings, and I'm going to tell it that I want to open it anyway. And then now it's starting. Okay, so I've got my lab here. I'm going to close this too. And so what I do is I like to keep the lab paper up and the lab simulation up at the same time, so then I can just go ahead and kind of read through it and do it that way. So let's see. It says we need to start the simulation. Here's our vectors. Okay, so I'm just kind of playing with it right now. Okay, just to kind of see what it does. So one of these is velocity, one of these is acceleration, and the way I can tell is if I say show one, there's only one, there we go, show the other, so if I try and move it around the same speed the whole time, the blue one doesn't show up, but then when I move it fast and slow, like speed it up and slow it down, I'm getting a blue arrow. So that's going to tell me that the blue arrow is acceleration and the green is velocity. Okay, and now I'm going to click on linear acceleration 1 at the bottom, like it says right here in step 3, and then I'm going to observe the motion. See what's going on with this guy. Okay, what is the direction between the size of the arrow and the acceleration? Okay, so, you know, as it speeds up, the acceleration increases, and then when it slows down, the acceleration goes in the opposite direction. So as it speeds up, goes in the same direction as the velocity, and then when it slows down, acceleration goes in the opposite direction. And this is because when you have a velocity or you have an acceleration and you're slowing down, you're basically accelerating in the opposite direction. The act of slowing down is an acceleration, but it's a opposite your motion acceleration. So now I'm going to click on simple harmonic like it says. Whoa. And a larger blue vector causes what motion? Okay, so it looks like if the blue arrow gets big, the ball will start swinging in that direction. Okay, then I'm going to click circular, like it says. Okay, so in order for the object to turn, the vectors must be at 90 degrees from each other. And you can see that. You can see as it's turning, the vectors are 90 degrees to each other. And that's because the acceleration vector is always going to point to the center of the circle, and the velocity vector is always going to kind of point towards the side, or like around the circle. Now I'm going to click stop. Okay, now I want to move the car like a runner on a racetrack. Okay, so basically it wants like an oval. So in order to turn, you have to change your direction, right? Let's see. I want to turn. Okay, you see that in the as I'm turning, and the acceleration will point to the middle. Okay, so that's that simulation. Okay, now it says it looks like we've got a different one. So I'm going to go to this website again. I'm going to download this vector edition simulation. Okay, it's going to do the same thing. It's going to tell me it can't open it. I'm going to go to my security and tell it to open anyway. And then there we go. Okay, so now I'm going to take two vectors. Here's my vectors. I'm going to put them out. I'm going to take them out of my bucket. And I'm going to change my direction and magnitude. Okay. Now when we do vectors, we want to do head to tail, or heads to tail, right? You don't want to place them like this. You want to place them like this. Okay. And then I'm going to click Show Sum to view the resultant. Okay, there's my resultant. Okay. And I can check on different styles to see different ways to show the components. Okay, and this is just different ways to show how to solve this problem, because you can see, let me make it a little more obvious. If I don't have a 90 degree, right, to get the resultant, we're not going to be able to just, you know, add them together. Or do the Pythagorean theorem. Okay, so here we go. And so I'm going to click on one of these vectors, and I'm going to fill in the table in the simulation. I'm going to show a grid. That makes me happier. I like to see the grid. Okay, so for vector 1, so what it's showing here, if I can get these back, my first vector, if I call this horizontal one my first vector, it has no R component. It takes a second to get it to click on that one. So, or it has no Y component. So I'm just going to -9. My theta is 0. My Rx is 9, and my Y is 0. So that's because it's totally horizontal. And then if I click on this guy, it's going to give me a different one. So I'm going to write this down. Okay, and yours will be different for this, right? Yours aren't going to be exactly the same as mine. This is just an example. If yours are exactly the same as mine, I know you didn't do the lab, right? And then I'm going to click on this resultant. Okay. And I'm just filling in the information from this top part of the lab right here. I'm not coming up with anything or anything like that, okay? So it says recreate as clearly as possible the vectors in this simulation. Okay, so to add the vectors, we're going to break each into its x and y components. Okay, so I'm going to take this x vector, okay, and to break it into the x and y components, you're going to use this formula. And I'm just going to write theta instead of, oh, here we go. I have theta actually saved. And then you're going to do okay. Now for mine, okay, my A is 9, and my degrees are 0. I'm outside, so you guys may hear cars and things. Okay, now I'm going to put this in my calculator. Again, this is just something that I'm just, I'm doing off the top of my head. So it's not like I've planned this or anything. Okay, so here's this first one. And I'm going to do 9. And notice I'm not using the calculator that came with my computer. If I tried to do that, it wouldn't work. It always puts it in radians when it shouldn't be. So don't try and use your download, like this was free GraphCalc or something like that. So because you want to make sure your calculator's in degrees. Sine of 0 is 0 times 9. Well, it doesn't matter, right? It's still going to be 0. And I'm going to get the same answers, see, that I got here. So that tells me that I did it right. Okay? Then I can do the same thing for the other vector. And I'm not going to solve that one, but I would do the same thing for vector 2. So this is vector 1, and this is vector 2. And then here's our resultant. Okay? So, sorry. The next question was the resultant. I was getting ahead of myself. So then you're going to do the same thing for the resultant. You're going to use these same formulas. Okay? And you see how I showed my work here? That's going to give me full points. And then it wants me to calculate the magnitude of the resultant vector. So what I have to do, if you look here, each one of these has its own little right triangle. Do you see that? And so what I'm going to do is I'm going to want the magnitude of this darker one. Okay, so for vector 1, I'll solve vector 1 and then we'll go. I'll have you guys do the rest. I'm not going to do them all for you. And since it's a right triangle, you can use your Pythagorean theorem. See if I can get these superscript for you guys. Okay, so I'm going to just put one of these here, 9 squared plus 0 squared equals something c squared. Now this is a weird one because it's completely horizontal. Okay, so you can see 9 times 9 is 81 plus 0 equals c squared. I'll turn it red in a second. So then I'm going to take the square root of 81 equals c squared. And then that's just going to be 9. I have to take the square root of c squared, sorry. I'm going to make this parenthesis. Okay, and that makes sense, right? It shows our resultant here was 9. Okay, so, and then you'll do the same thing for vector 2, and you can even do it for the resultant. Okay, you're going to use the same formula, except I'm just going to have you guys fill that in instead of me. Okay, and then you're going to do the same. You're going to use your we're going to do the same type of thing here. Okay, except here we're going to be calculating our uh-oh. I thought I still had theta as my okay, so I'm going to do tangent -1 theta equals, for vector 1 would be y over x, would be 0 over 9. Just make these, so hopefully this formula looks familiar to you guys. I'm going to get my calculator back. Okay. I'm going to do arctan, because that's what tangent -1 is, of 0 over 9. And I'm going to get 0. Okay, so my degrees are 0. Okay, which also, right, that confirms what I had up here. Okay, then you're going to do the same thing for vector 2 and your resultant. Okay, and then we want a screenshot of this. So I'm going to take that little screenshot and I'm going to plop it in here. You can keep it huge like this, or you can make it smaller. I'm going to make it smaller just to do it. And then this trial 1, we're going to kind of do the exact same thing. And you need to show your work for these. Okay, I put, let me go back to the website. If you go to the main page of our class, and you go to the 2D motion course resources right here, and you go to the vector addition lab, right here I kind of drew a picture, which is kind of what they did in the lab. It's not as pretty. And basically it's saying that you want to find the components of this first vector for that first one, so 5.8, and then you want to find the components of vector B, that's right here, and then you're going to find that resultant. And so basically the x component of that resultant is going to be this 4.97 plus this distance right here. Okay, if you see that triangle, it's like here, if this was a triangle. And then the y component is going to be this right here, this 2.99, and this 0.96. Obviously this isn't to scale, and this dotted line is the resultant. Okay, and then you can use the Pythagorean theorem to find the length of that resultant. Okay, and then that's this ax, right, that I found for this one, that 4.97 would go right here. AY is 2.99. So this bx would be 1.98, and the by would be 0.96. You need to show your work for this. I know I didn't, but you do. Okay. So the x component of your resultant is going to be 4.97 plus 1.98 equals 6.95. I'm going to make this a little smaller. And you can show your work in here too if you want to. It's totally fine with me if you want to do like ax equals 5.8 cosine do something like that to show your work. That's perfectly acceptable. Your ay is going to be these y components right here, so this 2.99 plus this 0.96 right here. Which is 3.95. Okay, so here's my answer. And then to get this, I would just do tan negative 1, the y over the x okay, so I get 29.61. Just make this smaller so it fits a little better. And then this one, you'd use that Pythagorean theorem for that. Why is it so skinny? Move it over. Okay, so then you'd have, 6.95 squared plus 3.95 squared equals c squared. Let me make these smaller. These are okay, so then I can put 6.95 here. Sorry. $48.3. Now I'm doing the 3.95 squared, 15.6. That's equal to c squared. So then we have 63.9 equals c squared. And then if I want to take the square root of that, I'm going to get 7.99. Okay, so that's my resultant right there. I'm going to bold that. Okay, so you can show your work in here. If you choose to do your work on paper, which, I actually recommend that, you can just, you can you can just attach a separate document to the lab or to the Dropbox that has your work in it, and that's totally fine. I just need to see your work in order to be able to give you full credit. But at least you've got some work here where I've, you know how we got this. And then you'll do the same for the other. And then you'll just answer these last questions, and that's your lab. Okay. You're not going to get full credit for this vector example point until you show your work, and it is just like your lab. So they kind of like have you practice it here, and then they have you kind of do it your way there, or do it, some other ones there. And so that's how you do the lab.